Okay, this is a video about a system that I installed for a neighbor. We had a natural disaster in the neighborhood and the power was disconnected from the utility after the disaster, and then for political reasons the local county refused a permit to re-establish the connection for the utility. And so this 75-year-old house had no power for 14 months after that disaster, and the owner had been negotiating with the county government to reestablish their electrical service for that time in hopes while running this diesel generator, and that just didn't work out. So I really wanted to shut down the diesel generator, so I adapted some stuff that I had laying around, and this is a little tour of that installation, which has been running for about 3 months now successfully. We had 2 separate overload events where the inverter shut down due to AC overload on one of the 2 phases, but besides that it's been running pretty good. And the air conditioning is running right now. We didn't modify any of the systems in the structure, so this is just a simple, inexpensive, off-the-shelf air conditioning system that a regular AC guy installed. And like I said, there's no there's shut off. There's no modifications to the system at all. And then this is just a steel job site box that I got, maybe, I don't know, it's like a $500 box. And there's 4 batteries here, all parallel 48 volt batteries. And then this is a little thermostat, and that controls these 2 heaters, which you've probably seen on other of my videos. These heaters are in between the 2 packs. And just like on other videos, I would mention the heaters are adjacent to the cells, not adjacent to the top of the pack. All of these packs have the temperature sensors at the top, so you can't heat the temperature sensors and have a good success. There is a lot of insulation in this box, and so we haven't had any trouble with the temperature. And then all of these combine in this fuse here. I think this is a 150 amp fuse, and there's a little bus bar down there for the negatives. And that's the battery system. It's extremely simple. This is mineral wool, completely non-combustible. I would prefer that the fire department show up and look at my steel box with non-combustibles and say, boy, that looks hot. This connection here is 2x0 to these connectors, and then it's 2 gauge thereafter. I intended to upsize this to 2x0, but it turns out the way the charger I have on the system is working, the loads are about 50 amps less on these cables than I had originally calculated for. And then this is a inlet, so it goes the opposite direction of a regular outlet, and this is how we feed the power in for charging the battery. And then that all goes into this enclosure here, which has this hole in the wall for a 3-inch electrical conduit, and that enclosure allows those wires to chase through into the inside. The original intent was to pack this with mineral wool to keep rodents out, but kind of forgot about that in all the excitement to get it running. So there's that. And then this generator isn't needed right now, but it still happens to be sitting here, and we set up a 30 amp twist lock because that's the connector that we used on the inside. And this house is adjacent to another structure owned by the same client. And so we ran a 10 gauge, or the client rather ran this, a 10 gauge 4-wire type UF cable underground, and it was 500 feet to this location here. Hence the battery and inverter, because you can't run an entire house on 500 feet of 10 gauge cable. So in order to make that system work, we set up a charger. Okay, so here's the mechanical area, if you will. It's a little kind of warehousey in this garage, pretty nice and organized. And so that 10 gauge cable is running this charger, which is directly connected to basically the bus inside the Outback here. And so there's a common connection between this inverter input, the battery, and the line side of the DC for the inverter inside there. And I have a 175 amp Anderson on here. And I also have a backup charger here with the same plug arrangement. So it's a 30 amp twist lock and 175 amp Anderson connector. So when this charger dies, the client can immediately switch over to this charger while we get parts for this one. I like this one a lot better because when the batteries reach a full state of charge, this inverter or this charger tapers back its output to the draw of the inverter. The output of that charger is a little bit more than 2,000 watts. Like we're 2.8 right now, so we're probably drawing about 400 watts from the inverter. Or from the battery, 400 watts from the battery. So it'll have 400 watts coming in on this cable from the battery, and this will be outputting a full 50 amps. We're doing 50 amps because that's putting about a 12 amp load on our AC connection to the grid, and we're running that 24/7. So we haven't had any problems. This property was drawing about 47 kilowatt hours a day, and that's way less than 12 amps 24/7 can supply. So we haven't had any problems. You can see its output over 1,000 kilowatt hours. That's the max the meter does. And I just set the voltage for the float voltage of the batteries, and it's a 30 amp twist lock. This inverter has a 30 amp twist lock AC input as well for the grid. Hang on, let me get the lights back. They're a motion sensor. This inverter has a 30 amp connection to the grid, so you can plug the inverter into here and charge the batteries. You wouldn't be able to use AC loads though, using the onboard charger, or you could plug this into there and use that, or you could use the backup, or in their case you could plug the generator directly into the inverter and use the inverter's onboard charger to recover the batteries. Any scenario using the AC input, you wouldn't be able to run AC loads because the maximum capacity of that really long wire is, 10 or 12 amps or something. It's not, the voltage drop would be too great. This loads panel at the bottom has all the standard connections, and I have an 80 amp circuit breaker on this charger, which is outputting 50 amps. And our loads are working and everything is pretty good. It has a 1450 I installed in the side of it here, which is connected via the 6 gauge cable up to this inlet. So this is a 50 amp CS63 California standard twist lock input, and it has its own disconnect here, which connects into the main panel of the house. Like I said, this is an old place. This panel is, I don't know, from the 60s. And that ties into this breaker down here. So you can shut it off here, but if you're shutting it off permanently, I would lock out, tag out it on that disconnect, because there is a sequence of opening doors and flipping switches where you could energize the live male terminals of that flanged inlet, which would become dangerous. And that's why it's also out of reach. It's up in the air where you can't get to it without a ladder. So the likelihood of accidental exposure is low. And that's the installation. Like I said, it's been running for about 3 months, and I really like it. It's a super great application of the low current phantom draw from a low capacity AC input, but a system that can handle larger outputs. When the air conditioning was running, we were up at about 4.5 kilowatts, and the batteries have been maintaining a really high, full state of charge for months now. But those 4 batteries can handle peak loads. So that's the system, and it's been working really well, and it has gotten the diesel generator shut down, which was my main goal. And so I'm really proud of that. So I hope that was cool. Kind of an interesting application of a low current grid connection using this charger. And if you're about to write in the comments, hey, don't you know that this inverter has an AC charger on board, I'm going to tell you some research that I did testing this thing in the field. And even though you can limit the charge current of the input, and the instructions really, when you read the Outback Radian instructions, it leads you to believe that there's a couple modes you could use that would help a low capacity AC source, but it is not true, and that is not how it works. And if you have information to the contrary to that, please feel free to put that in the comments. But my experience with it is, and I spent a couple of hours on the phone with Outback, every single time you give the inverter an AC connection, it immediately drops the inverter and starts the charger and transfers all of the loads to the AC connection. And so what ends up happening is even though you have a 10 amp maximum on its AC connection, it runs it up to say 25 amps and then throws in an error code and says, you're over current on your AC connection. And I'm like, of course I'm over current on my AC connection. Why did you shut down the inverter? And basically the system can only be an inverter or a charger, but it can't seamlessly switch between the two. So when I initially started this project, I wanted to use the onboard charger to charge the battery. When it was below that maximum threshold, I'd set it, say 12 amps, and then seamlessly transition into inverting once the loads rose above that threshold. But that's not my on-the-ground experience with this system. And if I did it wrong, I'll be sad. But having this external charger running as only a charger has been an awesome solution for this situation. Yeah, so that's my system, and I hope you like it. Thanks. Bye.